We're going to get started today. So welcome to the webinar for deploying highly available and scalable storage in minutes on the cloud. My name is Elise Arthurs and I'm the Director of Partner Marketing, and I will kick us off today with a couple polls. What we'd like to do is find out who's in the audience, and then we can tailor some of our information specific to the audience and what their experience is. So we'll launch the first poll now. If you can just take a look at it when it comes up on your screen and answer one of the questions, or select one of the answers rather. So the first one is about how much experience you have on the cloud today, and specifically when it comes to using infrastructure as a service, so providers such as Amazon or Rackspace. If you could answer this poll, and then we'll have a sense of just how much experience the audience has today with the cloud. Take a couple more seconds here. We see the answers coming in. Okay, well this is good. It looks like a decent amount of the audience has had some experience with serious projects, and then another good sized portion of you are starting to explore, and then just some of you are just starting to probably do your research here. So thanks for that information. Now we'll launch our second poll. And this is about just what's most important to you in terms of managing your applications on the cloud. And you select one of these answers. Is it availability? Is it performance? Is it manageability or scalability? We realize they're all very important, but just trying to get a sense of what's most important to you if you had to rank these. And we'll give it a couple more seconds. We see the answers coming in now. Okay, looks like number one thing is high availability. Okay, good. And then manageability. Well, I think you'll really like the content of this webinar then, because of all the different ways that we'll be able to talk to you about offering these different elements of managing your apps on the cloud. And we have one last poll. And this has to do with your needs for cloud storage and your challenges there. So if you could select one of these and give us a sense of what best describes your cloud storage challenges. Okay, a couple more seconds, and looks like we've got plenty of answers coming in. So it looks like most of you are looking for performance. Very good. I, again, think you'll really like the content of this webinar for that reason. And then second runner-up there is you need capacity. Okay, good. Well, thanks for that information, taking part in those polls. Now we'll get started, and I will introduce our panel of speakers today on the following slide. We've got Yuri Budnik, who's our Director of the ISV Partner Program here at RightScale. And he'll talk to you about RightScale and do some introduction to RightScale on the webinar. And then we've got Dave Garnett, who is the VP of Product Management at Gluster, as well as Craig Carl, and he's the Senior Systems Engineer at Gluster, and they'll take you through Gluster as well as the live demo. And then we also do live Q&A during the course of the webinar, and we have somebody online so that if you have questions during the webinar, just send them through the GoToWebinar chat box on your right-hand side of your screen, and he'll answer those questions, and that's Ryan McGinnis, who's a RightScale account manager. He'll answer them during the webinar, as well as we'll pull some of the questions aside and use them for our live Q&A at the end. And so please just keep the questions coming. We also record these webinars, and we post them about a day after the webinar, so that will be available for you to refer back to, as well as to send to colleagues or share with colleagues if you like. So our agenda today is pretty simple and straightforward. We'll do an introduction to RightScale, so you have an understanding of where RightScale sits within the whole cloud ecosystem. And then we'll introduce our newest partner, Gluster, and they'll take you through a live demo of using Gluster on RightScale. And then, as I mentioned, we'll do the live Q&A. So definitely make sure to send us your questions. We love the Q&A, and we usually have a lot of good back and forth with the Q&A. So keep those questions coming. And with that, I'd like to introduce Yuri Budnik, Director of our ISV Partner Program, and he'll get us started.
Thank you, Elise. So most of the presentation is actually going to be Gluster covering information about their technology, and especially a demo that you will see from Craig. But before we get started, and especially for those of you that don't know as much about RightScale or the cloud in general, we just want to give you some background information here to make it easier to put everything in context. So RightScale is software to manage servers you deploy in one or more of these infrastructure as a service cloud. And we've been at this for quite a while, by the way. We started shortly after EC2 launched, so we've been working on this about as long as anybody else has. And just so you get a sense of the scale, we launched over 2 million servers. In fact, if you go to our homepage, rightscale.com, there's a counter right there, and it's significantly past 2 million servers right now, by the way. In the logos you see is just a smattering of the different customers we have, and it's really across industries and verticals. Anybody that needs to deploy servers in the cloud and needs to manage them is somebody that can potentially benefit from the automation that we provide that you will see during the demonstration itself. And RightScale is really about making it easier and faster to deploy environments in the cloud and making it a lot less labor intensive to maintain them and to keep them running. And this is something else that you will actually see during the demonstration. You're going to see Craig actually stand up a Gluster environment, and for those of you that have worked in data centers before, you'll be able to easily tell the dramatic less amount of work that it takes to actually set that. That's because RightScale really sits at that intersection of the applications you want to run and the cloud infrastructure providers that you want to run them in. We're really an orchestration layer to simplify those processes. Lots of people talk about how the cloud might be less costly for the environments they want to run, but we really concentrate on this idea of agility, making it faster, giving your company more flexibility in the kind of things that they can deploy and the speed that they can do it at, and ultimately we think that's actually a more valuable benefit out of it. And that really goes tightly together with this idea of maintaining choice, of being able to deploy an environment in one cloud provider, one infrastructure as a service provider, but being able to move it to a different one if conditions or pricing or requirements change. That is because we have an abstraction layer between the definition of your application servers and how they work and the way they communicate with a particular infrastructure as a service provider. That's what makes that portability possible. And because quite a few of our customers and the people that use RightScale work in medium to large organizations, we provide this sophisticated user permissioning system and control capabilities so that you can give different levels of access to different people in your organization and only allow them to do or enact the changes that they're authorized to do, and also provide audit trails so you can then decompose who changed what when if you're ever troubleshooting a particular issue that you're trying to get to the bottom of. At the core of RightScale is this technology of server templates. And server templates are different than virtual machines or AMIs if you're familiar with Amazon machine images. In a virtual machine, no matter which kind it is really a big file with everything about that server saved in this big massive file. And you can clone and make as many copies of it as you want, but they're all identical to each other. A server template is like the DNA that will build the machine each time to be what it needs to be. And therefore, there's a lot of flexibility there because you can make some changes to that DNA, to that server template before you stand up that virtual server. So think of it as the difference between copying or burning CDs that you already made, and all you can do is make an exact copy of that CD. That's rather useful, but it's actually a lot better when you have a playlist, say in iTunes, and you can copy it as many times as you want also, but if you want to change the order of the songs they play, or if you want to change the songs in it, you can change that just as easily. That's really one of the main differences and main benefits of server templates, is the flexibility that they provide and therefore the automation that is possible with them. And once again, you'll see it implicitly in the demonstration as Craig is going through building up a Gluster environment. Oops, I forgot there was a build on this slide. So about Gluster, it's a great alternative to companies that need to store unstructured data. And think of the limitations of NFS, for example. You can stand up a single server that now represents a concentrated point of failure. There's a limitation on the number of storage you can attach to that particular machine, and there's also a limitation to the I/O throughput you might be able to get out of one server. With Gluster, you can take a number of nodes and create a contiguous namespace that's really composed of several machines, nodes behind the scenes, but to your application servers, they appear as a single storage resource. So during the poll, we saw that people wanted to look at more scalability. So if you're running out of storage in your storage pool, you can literally stand up another Gluster server associated with a storage pool, and voila, you now have more storage available. Or if you need more I/O throughput, you can, by standing up another server, get more ability to do reads or writes because you're talking to more servers, but without your application servers having to worry about the complexity of having to talk to different machines. From their standpoint, they're talking to a single storage pool. And once again, the real experts on this are the Gluster folks, and you're going to hear about that from them next. Before I hand the presentation over to them, I'd just like to call your attention to a couple of events that are coming up that you might be interested in. RightScale and Gluster are going to be together at BioIT World, which is next week. And not only are we going to be at the conference itself, we're actually hosting a cocktail event that we like to get to know and meet the people that are interested in technology, and most especially answer the questions. So please take note of the information on the slide if you want to attend. I believe we call it Cloud Conversations and Cocktails. And the other event is coming up in the summer months in June during Cloud Expo. RightScale will have is user conference. And that's also very much a user-centric, as the name implies, event where we usually have our customers present on the kind of project they've been building in the cloud and how it's been working for them. And we usually have some very strong showings of those, so you are most welcome to attend. With that, I would like to now pass the presentation to Dave Garnett, the VP of Product Management from Gluster. So Dave, you should see your screen pop in a moment now.
Great. Thank you, Yuri. I appreciate it. Hello to everybody on the phone. Thank you for joining us all. I wanted to kind of give you a quick glimpse into what Gluster does and what we can do uniquely, and why we've done it. So what are the big storage challenges everybody's facing in Amazon Web Services? The main points are high availability, performance, predictability, and scalability. Without Gluster, it's impossible to create a highly available POSIX storage file system. Redundant NFS is not possible within EC2. Obviously, NAS performance is limited to the speed of a single instance within EC2. As we see through NFS, that's around 80 megabytes a second. And if you want to go faster than that, you need to buy the very expensive high compute units to get their back-end 10 gig E connections. I'm sure we've all also experienced how Amazon performance can be unpredictable. I can't tell you how many times we fired up an EC2 instance and it will slow down, or speed up, or an EBS volume can even speed up and slow down almost 70%, hour to hour. NAS within AWS is also incredibly difficult to scale. There's a physical limit of 120 terabytes that you connect to a single EC2 instance, but it would be completely unusable at that scale through a single instance. So to get larger than that, you need S3, but again, your performance is terrible, and you would need to rewrite your applications to leverage the HTTP get-put type interface instead of the normal storage. So what we did, we created Gluster as the only way to implement highly available file system within Amazon. We limit that performance vagaries that we see of machines slowing down and speeding up. By being able to cluster them together, we can guarantee a straight line of performance. There's no limit to the speed of a Gluster cluster, no limit to the number of files of a Gluster cluster, and again, those are both regardless of file size, block size, etc. We have designed the system to work across availability zones and with S3, so we're able to give genuine high availability storage within the cloud. Again, because of our great partnership with RightScale, we can go from concept to production in about 30 minutes and have 2-hour support guaranteed. So when would one use Gluster, when wouldn't one? Again, Gluster works incredibly well for unstructured data, video files, audio, pictures, etc. We recommend not using Gluster for databases, for data where on-disk block order matters, or for structured files. So just quickly a look at performance. The thing I want to highlight here is that in Amazon, Gluster's been benchmarked at 5.3 gigabytes per second of aggregated throughput. And it's really the only way to get that level of performance in Amazon with NAS. Again, just to be completely fair, single file performance is limited to the instance on which the file exists, which would be 80 megabytes a second. But again, I think we're all looking at the aggregated storage of the cluster. So from there, I would like to toss it over to Craig for you guys to see how easy and fast this actually is.
Hello, everybody. How are you? Great. All right. So let's get started. Let me get rid of the. Come on, go away. There we go. Get rid of this and go straight into the RightScale interface. So those of you that have used RightScale before, you know that one of the things that they do is they make Amazon Web Services incredibly easy to use. What you're looking at here is what we're going to build towards, which is going to be 8 instances of Gluster up and running and providing 132 terabyte single NFS export across multiple availability zones. And so this is what we're working towards. So let me show you how we get there here in the RightScale interface. We start off with a smaller cluster that we then need to add instances to. So in this case, I've got our first 3 instances built, and I need to add an additional instance to it. So we go ahead and we choose Add a Server. And we're going to add a Gluster storage appliance. For simplicity, I'm going to call it Node 4. I'm going to put it in our security group. And I'm going to choose a different availability zone than any of my other machines are in. That way, as Gluster is built and gets larger, it's redundant across availability zones. So I just make sure I put machines in different availability zones, and we choose Add. And then all we need to do is launch that instance.
So Craig, real quickly, what happens if an availability zone fails?
If an availability zone fails, by default, your data exists in 2 availability zones. So the loss of any single availability zone does not affect your application at all. Your data is still available. The Gluster client deals with managing a failed instance and repairing that instance when it comes back. So that instance is launching. And it'll take about 10 minutes to launch and be added to the cluster. Okay? Now once you've added your 4th machine to your cluster, you now need to attach storage to that cluster. Oh, that's nothing to worry about. You now need to attach storage to that cluster. We have operational scripts to do this. Those of you that have used RightScale know that operational scripts are ways to make tasks easier to perform. So if we come up here to scripts, and I'm going to talk real quick about some of the other scripts here. First script we're going to use is provision of volume. So in Gluster, when we take EBS volumes and we attach them to all of the instances and we expose that into a volume, and then we export that as NFS or the Gluster FS protocol. Some of our other operational scripts are EBS scavenge, allows you to upgrade an instance. So if currently you were running on M1 large instances and you wanted to move to M1 extra large, that script would allow you to do it online and with no downtime. Okay, so let's go ahead and run the provision volume script. We only need to run it on one instance, and it doesn't matter what instance you run it on. In this case, we're going to build a EBS volume called distribute. This is a vanity name. You can make this whatever you want. It would likely be photographs or videos or whatever you'd like to make it. In this case, I'm going to make it 50 terabytes, and we're going to make it a type of distribute. Gluster can run in two different types, distribute and replicate. Replicate is redundant, but costs more money from Amazon because you have to buy more storage, because we're mirroring. You also have distribute, which is non-redundant. So we run that operational script, and it'll take a couple of hours, and you'll have a 50 terabyte NFS mount point that's available to you.
Can you quickly explain what the different protocols are that we can use to access storage?
Sure. So Gluster works only at the POSIX layer. So any protocol you use is going to look completely normal. It's going to be copy commands, move commands, all the standard commands. We can use NFS, which is sort of the standard protocol that everybody uses. You use mount-t NFS. We can use our own over-the-wire protocol, which is Gluster FS. It works the same way. It's mount-t Gluster FS. But in the back end, it's completely parallelized, and that's how we handle the high availability of a Gluster file system. Is with our protocol, you connect in parallel to every node of the cluster simultaneously. We can also export using Samba out of the box. So those are the protocols that are supported from the get-go. All right. So let's go look at what we've built. And it really is that simple. You take one node and you start adding additional nodes to it, and then you create the volume just the way that we've created the volumes. And what you will work your way up to over the course of, and I think this took me about 2 or 3 hours, is you have 8 instances up and running very quickly. As you can see, some of the instances are in 1A, some of them are in 1B, some of them are in 1C. That's for redundancy and availability. So if we lost US West 1A or 1B, there would be no impact. Your data is stored in multiple availability zones. Using this storage is very, very straightforward. Let's see if we can't make that a little bit bigger and easier to read for everybody. Give me just a second. All right, is that a little bit easier? Good. So if I ran a mount command. And I mounted it here. So it's that simple. It's a standard Unix mount command. No difficulty there whatsoever. And once you have it mounted, we go look at the size. And as you can see right here, we have a 132 terabyte file system attached. Now this is a single file system. If I go ahead and CD in there, I can now do all of my directory structure, remounts, everything you would normally do with a file system. You can put all of your website's photographs or all of your audio files or all of your video files in this single mount point. You can access this mount point from hundreds and hundreds and hundreds of instances. You no longer have to worry about maintaining 10, 15, 20 NFS servers and keeping track of where they all are. You don't need to worry about all of those mounts and maintaining all of those mounts on all of your systems. You can use one mount to access hundreds of terabytes of storage. You can access this data simultaneously using Samba and NFS and Gluster FS. And it really is. I know this looked very simple, and that's because it is very simple. With RightScale, we can move all of the work up into their web interface, so you never actually have to SSH on to any of the machines ever. There are even operational scripts that you can run against your hosts that automatically mount the Gluster cluster and automatically update FS tab. So you can go so far as to build your entire cluster and then mount it without ever SSHing into a machine. And that pretty much does it for our demo. Oh, one last thing real quick. When we say that we protect against the vagaries of performance and the way that performance changes and goes up and down in Gluster, I want to sort of give an example of that here. This file system, this 132 terabytes, is spread across 8 instances of Gluster, which means 8 virtual machines. It's also spread across so I'm doing a little bit of math. It's also spread across 192 EVS volumes. So you don't have to deal with the math, you don't have to deal with the details, but there are actually almost 200 EVS volumes behind this 132 terabytes. And we do that for performance and reliability as well.
So you're adding a lot of EVS volumes, and does that cost more from Amazon to do it that way?
No, there's no difference from Amazon if you were to attach 100 1 terabyte volumes or 200 500 gigabyte volumes or 1,000 1 gigabyte volumes. They care about the amount of space and not about the number of volumes. So that pretty much wraps up my demo. And I think at this point we open it up for questions.
So Craig, this is,
So
I was going to say, let's begin the Q&A. This is Yuri from RightScale speaking. We've been receiving questions via the chat facility during the webinar, and I believe you actually have some in front of you. The bulk of the questions, by the way, are Gluster. So please go ahead and tackle the questions on your list. You have the questions in front of you? You want me to read some?
Yeah, no, we have them.
Okay.
Okay, question. At the end, can we speak about the interface of Gluster to the underlying storage? What are the examples of the underlying storage that can be used with Gluster?
So Gluster is exposed as a POSIX file system to customers, and it uses POSIX on the back end. So what we're doing on the very back end to make up the cluster is we are attaching EBS volumes. We're creating RAID arrays out of them, and then we're formatting them with ext3. And that's what we're doing on the back end. And then when your application accesses it, it accesses it like an NFS mount point. And that's what it looks like. There's no API to program. There's nothing like that. It's just like you were making and copying directories in your Windows interface or on the Linux command line.
So next question. How is the data stored on the Gluster nodes? What happens on a failure of a Gluster array? And how can one recover the data if Gluster itself fails?
Okay, sure. So the data is stored in a POSIX compliant format on the EBS volumes. If Gluster went away completely, you uninstalled Gluster from every machine for some reason, your data would be untouched. Gluster doesn't break up the data. It doesn't store the data in any strange formats. If you look at the data on the back-end disk, it looks just like your regular data. As a matter of fact, you can take snapshots of those volumes and then restore them and run Gluster from them without a problem. So there are no issues with Gluster chunking up data and making the data difficult to get to.
Okay, another good question. What is required to support this capacity or capability in a private?
So Gluster ships several versions of our product. We ship a VMware OVA. We ship a Zen OVA, a KVM OVA. So you can run this exact same virtual machine on VMware Zen and KVM, in addition to RightScale. Now, I did notice a good question. What is the host in the mount command? In the mount command, that host that I simulated in there is any EC2 instance running Gluster. Any of your EC2 instances running Gluster, and that's what you mount to. Okay?
So are there any questions on the RightScale side?
Let me read the question here first. Is the RightScale user interface that gives access to the Gluster technology? I'm sorry, is it the RightScale user interface that gives access to the Gluster technology, or does Gluster have its own user interface? Craig, I want to say something about this, and maybe you can help me add a little bit of information here. Think of RightScale as your management front end for all the servers you're deploying. In working with Gluster, we created a series of scripts that allow you to automate a lot of the procedures that you would otherwise be SSHing into the machine and doing manually. So in a manner of speaking, you use the RightScale UI to look at the different operational scripts that are available, to run them, to give them parameters, and to be able to configure things as you need. Would you like to add something to that, Craig?
Sure. There is a Gluster interface. There is a Gluster command. I'm going to pull it up here real quick, just so everybody can see it. That's the Gluster interface. It's a single command. Now, of course, using RightScale, you would very rarely need to come in here, because we've moved a lot of this functionality out to operational scripts. But should you choose to, there is the Gluster command, and you can come in and run things directly on the Gluster instances. And you can choose to do some things with operational scripts and some things on the command line. It's entirely up to you. Okay?
So I'll let you guys take the next question since I think you have many more questions than we do.
Okay, so we're talking about...
Actually, let me read the question. All right, question. To stream a large file from a website, does Gluster first have to transfer the entire file to the server before it is available for reading? Or can the stream begin as the file is being transferred from the back end?
All right, that's a great question. If you manage to make it over to Gluster.com, you're going to see one of our big customers is Pandora. So obviously doing lots of streaming of audio, and the question applies for video. No, it doesn't. Sort of the way that a POSIX system works is whatever application you're using to stream video, let's say you're using Apache or some sort of Flash application, is actually going to go request the first megabyte of a file or the first 500K of a file, and then we'll begin to stream that to your application. So no, everything happens on the fly and very quickly. We've got a good technical question. In the instance you've chosen for your host parameter in your mount command is the one that fails. So I think what the question is leaning towards is when I run that mount command and I put in a host name, what happens if that host fails? The answer is nothing. That host command is just, or that host is used just for the initial connection. As soon as it's made the initial connection, it discovers all of the other nodes in the cluster and it connects to them simultaneously. So the fact that that machine failed is completely irrelevant. The only rule is when you go to issue a mount command, the command you issue the mount against, the host you issue the mount against has to be live at that time when you make the mount command. It can, if it happened to crash and disappear 5 minutes later, and you wouldn't have a problem.
Okay, question. How is data transferred between Gluster nodes, and are there ways to encrypt the data?
Okay, so if you're using the Gluster file system client, there is no inter-Gluster communication. We actually lifted up the sort of things that you would expect to be happening between Gluster nodes, and we moved a lot of that up into the Gluster cluster. And then on top of that, we removed the need for a vast majority of it. There is no metadata. There aren't any lookups. None of that stuff is happening. So using the Gluster file system client, there is no inter-cluster communication except for configuration-related data. No user data transits between Gluster nodes.
Okay, here's a good question to talk about distribute or replicate. Is all of the storage exposed? For example, is a 100 terabyte Gluster volume comprised of 100 terabytes of EBS, or is there redundancy that requires more than 100 terabytes of EBS?
Certainly. So if you want 100 terabytes of usable space and you want to be redundant, we're going to use 200 terabytes of EBS devices. If you don't want to be redundant, then we have about a 5% overhead. So we would use about 105 terabytes.
Okay, good question here. How are you able to get 5,300 megabytes per second of throughput over an infrastructure that only supports 80 megabytes per second?
That is an excellent question, right? And so what we're talking about is our aggregated file system performance. And so that 5,300 megabyte per second number came out of a set of tests we ran, and we have a document that everybody can get access to for these tests, where we created a Gluster cluster in Amazon of 64 instances. 64 instances times 80 megabytes per second is 5,300 megabytes per second. And we have other, we've done lots and lots of testing. We have lots of experience here. But 5,300 megabytes per second is 64 instances, each instance operating at about 80 megabytes per second.
Okay, what is the read rate when two clients read the same data?
Sure. So reads are cached into memory. So if two machines are reading the same data, then they're going to be reading that data out of cache. So it's going to be very, very fast. Okay? If you are attaching using the NFS client will have that cached locally on the machine as well. So it's going to be even faster. Another good related question, if you're replicating, which means you're storing 2 copies of each file, we read from both copies. So in a replica environment, reads are faster because we will read from both copies simultaneously. Half your reads go to one copy, half your reads go to the other.
Good. How does replication work when using the NFS protocol?
Sure. So basically what's happening is you're connecting to an NFS service on each Gluster instance, and then the Gluster service on each instance is replicating the data. So there's an extra hop involved when using the NFS protocol. It's still synchronous in that your application won't receive a commit until it's been written everywhere. Starting in Gluster version 3, which came out several months ago, we took the NFS server and we integrated it into Gluster. So it's now part of our process, and that helped us make it very, very fast. So NFS is a great alternative to GlusterFS. The only downside is if you are mounted to an NFS, if you're mounted via NFS, and that instance that you're mounted to fails, you have to remount to another instance. And we have ways to do that and make it very quick, but there is a quick disconnect and a reconnect when you're using NFS and there's a failure. If you're using GlusterFS and there's a failure, that doesn't happen.
Okay, could we please clarify the prerequisites for configuring a Gluster cluster? Should we have some sort of cluster infrastructure like for GFS, or can it be installed as a standalone independent system?
Absolutely, completely standalone and independent. I'm going to go back into my, my GUI real quick. This is it. This is the entirety of our Gluster infrastructure that we're talking about. That 132 terabytes is running on those 8 instances. And that is the entirety of the infrastructure. Okay?
Okay, in a non-replicated setup, is there any protection from outages?
There is not. So if you are running in a distribute format and you lost an instance, the rest of your cluster would continue to operate. Only the data on that instance would become unavailable.
And what happens when that instance comes back up?
That data, when that instance starts, it communicates with all of the other instances. It says, hey, I'm back, and data access starts again.
Okay. If I have 6 client nodes and need auto failover between the 6 client nodes so that if any one client goes down, everything still works fine, how would I connect to Gluster?
Absolutely, the Gluster file system client. It's a mount command. It works on any 64-bit Linux environment. And you would definitely use the Gluster FS client.
Okay. What type of encryption can be used when writing data from Gluster client to Gluster bricks?
Sure. So Gluster follows the ethos that we're a very specific program that does a very specific thing very well, but we integrate with all of the other Unix tools very, very well. So you could choose to use IPsec, would work just fine. You could choose to VPN from your clients to your Gluster instances. We have Gluster running up in VPCs, so that data is encrypted. Any sort of standard Unix-based IP encryption is going to work just fine.
So a question around Amazon pricing. Let's say I want 100 terabytes of redundant storage. What is the cost per terabyte going to be?
So Amazon charges 10 cents per gigabyte per month. So if you wanted 100 terabytes redundant, you would actually need 200 terabytes of storage, and that would be at 10 cents per gigabyte per month.
Is there an API to directly access the data? Can a client update a file? Is it possible to read a file starting at an arbitrary point in the file?
Yeah, access to storage stored by Gluster is via POSIX. So POSIX does have semantics to access a file, certain parts of a file. So in that case, absolutely. But it's going to be just like you mounted. It's going to be POSIX, just like NFS. So that's how you're going to access the data. Well, so we have a question about Ceph. Ceph won't work in Amazon. That's sort of the big comparison in this case. Lustra, Ceph, DRDB all require a floating IP. They all require a virtual IP. And that's why they won't work in Amazon. Gluster doesn't use floating IPs, so Gluster works well in Amazon. And that's one of the reasons that a lot of this stuff is really difficult to do, because before a lot of those other tools that people are familiar with won't work in Gluster because of the pretty severe limitations won't work in Amazon because of those severe IP limitations that Amazon puts on you.
Okay, with the same 6 client nodes, if I need more redundancy from Gluster, can I use 2 separate clusters? If one cluster is unavailable, all 6 nodes can still access the data with no downtime.
Sure. So when we talk about storing 2 copies of your data, that number 2 is arbitrary. I can store 3 copies of your data. I can store 4 copies of your data. I can store 5 copies of your data. So it just depends on what your level of comfort is. You could easily create a Gluster cluster that stored 4 copies of your data, 1 in each availability zone. So if you wrote a 1 megabyte MP3 file, we would store that file in all 4 availability zones. And so we can be as redundant as you need us to be.
Good question here about geographic locations. Is it possible to have Gluster bricks in different geos, like US West, US East, EMEA, APJ, etc.?
Sure. So today, yes, but it can be slow. We have a geo-replication feature going to be in the next release. We expect that to be out in less than 30 days, at which point geo-replication will be fully supported. So we're asked about the relationship to Hadoop. Gluster is its own project. It's different from Hadoop in that Hadoop is object-based storage. And it chunks up the data. Gluster doesn't chunk up the data, and we're not object-based storage, we're POSIX. You don't need to write to an API to access data from Gluster.
So in our benchmark test, did we use normal gigabit Ethernet or 10 gig E or fiber? Just to reiterate, the tests that we've shown were on Amazon, on M1 Large.
Yes. Yeah, so all of the tests and all of the numbers you've seen were on Amazon M1 large instances. So that would be 1 gigabit.
We also do have a performance white paper that we would love to point you guys to on our website. And that can show both the on-premise solution through the VMware, Zen, and KVM hypervisors, as well as the Amazon instance through RightScale.
In a geographically distribution of bricks, will a client in a random location be smart enough to read from the closest brick? Yes. In Gluster version 3.12, we added the functionality to read from the fastest location. So about, every X number of minutes, your client goes out and says, what's the fastest brick to me right now? It actually goes out to every brick and says, how fast is every brick? And then it always reads from the fastest location, which in theory will be the closest location. But faster is better than closer. And I hope that answers that question.
What would perform better for a read-only environment? 32 replicas or 2 replicas on 16 nodes?
Absolutely worth testing. One of the great things about RightScale and Gluster is you could have both of these up and running in a few minutes. Usually, it would be 2 replicas of 16 nodes. That's what I would expect to be faster.
Okay, we don't want to completely stay away from RightScale. Is there any questions over there that you'd like to answer?
Sure. I have a question here, and Craig, maybe you can help me by going back to the web browser and showing the library. I have a question about how do you find the Gluster server template in RightScale. Craig, if you could switch back to your web browser there, and just scroll to the top of your screen and show under under design server templates. Oops, design server templates. Then scroll to the right. It says server templates. Click on that, and from there you notice that we actually have Gluster as a feature server template at the moment. By the way, this is what somebody would see that's logged into RightScale. But you can access the library for browsing purposes even if you're not logged in via rightscale.com/library. So even if you're not using RightScale today and you just kind of want to browse this and read the information about Gluster, it's available there. But as you can see, it's very easy to find. From there, can you click on the server template, Craig, so I can show people that there's an import button? Once you're actually browsing a specific server template, all you do is click, because you're not, you can click a button to import into your own library. That means you can use it. And another thing that wasn't really in this question, but just to explain to people, well, actually, in this case, Craig already has it in his account. That's why the button didn't say import, because he's already done that. So he's got access to his own server template, as you might imagine. The other really nice advantage here is that because we work very closely with Gluster, all you need to do is import it and start using it. And without getting into the specific pricing info in this discussion, the cost of the Gluster server template is part of your bill you get from RightScale, so you don't need to enter into this whole separate negotiation and contracting process. We make it very easy for you to just start using it. And of course, you can contact one or both of us for any kind of technical discussion or question about that. So I think we only have time for 1 or 2 more questions. Dave, I see that we're getting close to the top of the hour, and we want to be respectful of people's time. So if you guys have a couple more that you want to address, maybe we can do that now.
Okay, 2 more questions. Did monitoring get added to the RightScale interface for Gluster specific items like disk I/O or performance to each server?
So Gluster 3.2, which is out in 30 days, adds a whole set of features to the Gluster core. specifically two tools, Gluster Top and Gluster Profile. Those provide lots and lots of information about the performance of Gluster. The RightScale templates will be updated to reflect those as soon as that product is released. Okay? And that again, about 30 days, and we'll have better monitoring in there.
So last question, or if we can get two in real quickly, are there any hidden tricks for the back-end file system, like make ext3 -L256 for putting a journal on the extra disk, etc.?
So yes, there are lots of tricks like that that Gluster takes care of. When you go to provision storage, what that RightScale script is doing is it is going out to Amazon. It attaches the volumes. It provisions the volumes in your Amazon account. It attaches the volumes. It creates an MD admin array. It formats it with a bunch of options. It mounts it. It sets mount options. It takes care of all of that for you. So yes, there is a bunch of stuff. No, you don't have to worry about it. Last question.
Is elastic resizing of storage supported?
Yeah, and we really wanted to fit that question in. Yes. So right now, we have 132 terabytes in that distributed file system. I could grow that online without any downtime to any clients to, say, 500 terabytes. And again, that would be online. It would happen in the background. And as that space became available, it would become immediately available to all of the clients. Support completely dynamic growing and shrinking, if you need to, of the file system.
Perfect. And with that, we would like to thank everybody for joining the webinar. And everyone have a fantastic day. And we have our contact information up on the screen. And we'll get back to any questions you guys ask us.
Dave, I would just like to remind people of a couple of things here. There were lots and lots of questions, and we're more than happy to talk to you individually about your specific needs. So as Dave was just saying, you can reach out to either of the companies and you can talk to us jointly. And also there were quite a few questions about whether the presentations would be available later. And as you can see, rightscale.com/webinars. So for anybody in your company that might want to see this later, or if you want to review, that is, of course, available for you at your convenience. So with that, and sorry for interrupting you there, Dave, with that, I would like to bring the webinar to an end. Thank you for your attendance, and I look forward to speaking to some of you personally.